In this video, we'll go over the idea of reflections, and just like before, we'll go over the animation together, and then we'll take up the questions. So what I have here is our parent function, f of x, and the transform function is h of x equals a times f of x. And I actually spoiled it for you. I made a to be -1. So let's change that back. Okay, so now a is equal to 1. And what I'm going to do is when I click on this button, it's going to change a from, it's going to alternate it from 1 to -1. Okay, so when we're alternating a from 1 to -1, you see that what happens when a is negative is a reflection with respect to the x-axis. Now, why does that make sense? Because take a look at the equation of h of x. You're taking a times f of x. So what you're really doing is changing the signs of the y-coordinates from before. Right? If they were positive, now they're negative. If they were negative, now they're positive. So if you think about that, if you're changing the signs of the y-coordinates, then you have a reflection with respect to the x-axis. So I know we're the parent function right now is the quadratic function, but we're going to change it to, I don't know, let's say square root of x. See, same thing. It doesn't matter because look at the y values, right? They used to be positive and now they're negative. Are the x values changing? Absolutely not. Okay, so that's why you see this beautiful reflection across the x-axis. So now let's see what we have here. So parent function. Now here, let me just move these over so you can see. So f of x equals x, and h of x is f of kx. What I'm going to do is alternate the sign of k. So if it's 1, it's the same function, but alternate the sign, okay? So it goes from 1 to -1, 1 to -1. So if it's -1, now this one's a little tricky because you can visualize this as a reflection with respect to the y-axis or the x-axis. So you know what? It's because there's something special about the linear function. So I'm going to make it very obvious. So it's okay. So now if it's the square root of x is our parent function, it is very clear that when k is -1, you're applying a reflection with respect to the y-axis, not the x-axis. It is very clear that it is with respect to the y-axis. So why is it with respect to the y-axis? Because now you're affecting the input, right? You're affecting the input. You're taking the previous x values, and what are you doing? You're multiplying by -1. So if that's the case, then you have a reflection with respect to the y-axis. The y-coordinates are untouched; they're all the same. It's just the x values. So they used to be positive, now they're negative. Okay, so I'll let you think about that, and I'm going to reflect it with respect to both axes here. So this is supposed to be negative f of negative x. This will reflect with respect to both axes. And the reciprocal function is actually very interesting. If I reflect it with respect to both axes, I actually have the same function. I have what I started off with. And that's because I don't want to talk too much about a grade 12 concept, but that's because the reciprocal function is special in the sense that it's an odd function. If you reflect an odd function with respect to both the x and y axes, you will get the same function. You'll get the same graph as before. So the reciprocal function is odd, and the linear function is also odd. What is not odd? The root function. So the purple is obtained by taking the blue and reflecting it with respect to both axes. Okay, because now I'm not just manipulating x, or y. I'm manipulating both of them, both of the coordinates, and changing the signs. Okay, so that's the animation for reflections. Okay, so hopefully the animation was helpful. Let's answer the questions. Describe how the graphs at y equals f of x and y equals minus f of x are related to each other. Well, since I'm taking the previous output values and multiplying them by -1, related by reflection with respect to x-axis. So this is something you should be comfortable with because this is what you did last year when you transformed a quadratic function. You reflect it with respect to the x-axis, so it went from opening up to opening down. Describe how the coordinates of the original function are changed after reflection in the x-axis. So they used to be xy, but now they are x negative y. Okay, which points are invariant after reflection in the x-axis? So invariant means the point does not change. Okay, the point remains where it used to be after you apply the transformation. So the only way for the point to be where it was beforehand after reflection in the x-axis is if the point was located on the x-axis. So you can say x-intercepts, because any point on the x-axis is an x-intercept. Okay, describe how the graph y plus f of x and y plus f of negative x are related to each other. So now we're not manipulating the output, we're manipulating the input. So they're related by reflection with respect to y-axis. Describe how the coordinates of the original function are changed. So they used to be xy, but now they be negative xy. And if you want to be invariant after reflection in the y-axis, then you must be on the y-axis. So y-intercepts are invariant. And I'm going to say, since we're working with function, then you only have one y-intercept. You can't have multiple y-intercepts, because then you won't be passing the vertical line test. Okay. Describe how the graph... Okay, so negative f of negative x. So we're reflection with respect to both axes, both x and y axes. Let's say both x-axis and y-axis. All right. Determine how the coordinates are changing after you reflect along both axes. So if it's xy, now it's going to be negative x, negative y. All right, I think we're good. Let's see. Now we are going to determine the equation of each transform function, g of x, after the indicator reflection. So if I'm reflecting with respect to the x-axis, so g of x equals to negative f of x, because I'm reflecting it with respect to the x-axis. So that's negative x squared. All right, that's the equation. Now, this question is actually a very nice question because we are now transforming a function which is not one of our parent functions. Okay, we saw that in the previous day's homework. So this is a very nice question. I don't really want you to box yourself into thinking that I have to transform our parent function. You can transform a transform function. You can transform any function. Okay, so yes, this is, you can think about this. You can think of f of x here for 1b. You can think of it as a transform linear function. I'm going to take this transform linear function and I'm going to transform it again. So g of x is equal to f of negative x, because I'm reflecting it with respect to the y-axis. So using function notation, if f of x is 2x minus 3, then f of negative x is 2 times negative x minus 3. So that's negative 2x minus 3, and there you go. All right. G of x reflect with respect to both x and y axes, so both axes, so it's negative f of negative x. Function notation, so f of negative x will be negative root of negative x minus 3, right? So just stick with what you remember from function notations. So negative, negative, that's positive. That'll be negative x minus 3. Beautiful. This is a really nice idea. You're transforming anything you want. If you truly understand transformations, you're not stuck in a box. You don't have to transform parent functions. So g of x equals negative f of negative x Alright, so function notation, f of negative x. Everywhere you see x, you replace it with negative x. So this, I'll take it slow here. Alright, so this is a lot of negatives here. So if you factor out negative 1, there's a common factor of negative 1, so that can simplify. And there we go. That's the equation of g of x, the transform function. So hopefully that's not that bad. Really, it's an application of what you learned earlier, which is function notation. So that's the lesson on reflections. You can reflect with respect to x-axis, with respect to the y-axis, or with respect to both axes. And then we have one more set of transformations to go, which is stretches and compressions.